Dear friends, in this video, we'll discuss about the lead time versus cycle time. What is the difference between these two matrices? How it helps us to improve the efficiency of a software development and other processes. You might have listened in the agile world development. The targeted development duration and the actual development duration, there is a lot of differences there. Okay, dear friends, in this video, we'll discuss about the differences between the lead time and cycle time, how these two matrices helps us to improve the efficiency of a software development. In the agile development world, you might have heard the actual time and the planned targeted dates is always vary. So the difference between this actual and the planned duration and the reason for this we need to discuss. If you understand the reasons for this, then only you can improve the efficiency of software development. To go in detail, first we'll understand what is the lead time and cycle time and what is the definition of it. Lead time. Lead time is the total time it takes from the moment a request is made until the requested work is completed and delivered. It includes all the time spent in the queue waiting for the resources actually working on the task. And cycle time is the time it takes for a work item to move through active work process from the moment work begins on it until it is completed. Here you have to see the difference here. Time spent on the queue waiting resources is not there in this cycle time. Actively working on the task that is only there in the cycle time. From the moment work begins on it until it is completed only in the cycle time. It does not include the waiting time or the time spent in the queue. There is the major difference between the lead time and cycle time. So from these two definitions, you can understand that lead time is always more than the cycle time. Even the sum of the cycle times is always less than the lead time. Okay, you'll see an example here. For example, I've taken four features for development. Feature 1, feature 2, feature 3, and feature 4. I've taken lead time and cycle time. Okay, two important matrices to understand the how development efficiency is varied. Across all features, lead time is given. It's all parameters are given in days. Okay? Lead time is 20 days for the feature 1, second is 15 days, 20 days, and 5 days. All features. If you see the cycle time for the development, cycle time for the QA, and cycle time for the production deployment is given in days. Cycle time for the development for the feature 1 is 10 days, is here is 8 days, here is 15 days, and it is 2 days. If you see the differences, if you observe the differences, here the development effort is 10 days, here the development effort is 8 days. When you understand the duration taken for each cycle time and the wait time between these different phases, if you eliminate these, efficiency will be increased. Example, if you see here, lead time is 20 days. Here, development is 10 days, 5 days, 7 days. How much is total? 10 plus 5 plus 1 is only 16 days effort. But where the 4 days went? 4 days is last. It's due to multiple reasons. Maybe after the work is assigned, development is not picked immediately because the resource is not available. Maybe resource does not have the skill set. Or maybe during the development, the requirement has been changed, or after the development is completed, it went to the QA, but QA has not picked it immediately. Or maybe during the development, the review might have been taken more time. Yes or no? So there are different factors involved. This for the 4 days loss. And if you observe the differences between the development effort For the feature 1 and feature 2, 10 and 8 days. Okay. Here it taken 10 days and it is taken 8 days. Okay. So what is the reason for reduction of this development effort? Did we improve ourselves, or the feature itself is a less complexity? You have to understand that. The feature of the same estimate size, but still the development effort is taken less, you have to implement the same for the next features as well, so that you can improve the development efficiency. And if you go to the third feature, first feature and third feature, the lead time is 20 days only. But the development effort is 15 days and the QA effort is 3 days, production deployment is 1 day. But why the development effort has taken 15 days? Okay, assume the development has done perfectly. It has taken 100%, effectively has taken 15 days. 15 plus 3, 18 plus 1, 19 days. Only means that only 1 day is wasted as a either it may wait time or waited in the queue time. Right, yes or no? So with the feature 1 and feature 2, the difference is the wait time has been reduced from feature 1 to feature 3. That is one of this uh, hint for you to say the wastage has been reduced. But you have to understand the development effort has been increased from 10 days to 15 days, even though lead time has given you as 20 days to deliver the product. Why this development effort has been increased? You have to see in a micro level. Isn't it difference in the development team, or any new team members has been added, or the efficiency of the team members may be reduced or more? What are the reasons for this development team has taken more time? Then only you can improve the efficiency of this product delivery. And if you see here the fourth product, feature 4, 5 days is the lead time, development has taken 2 days, QA has taken 2 days, production deployment has taken 1 day. Here there is no wastage of time. All the days is effectively utilized. The feature on feature, the wait time has been reduced. Okay, so that is the major difference between wait time and cycle time, lead time and cycle time. What are the reasons for this more lead time? Okay, because the summation of all the cycle times is always less than the lead time. The reason for it is queue time. Work items may spend a significant amount of time waiting in a backlog or a queue before they are actually worked on. This can be due to a backlog being too large or insufficient prioritization, or the resource constraints is there. So the ticket has not been picked. Dependency on external teams. Sometimes the completion of work item is delayed because they are dependent on other teams as well. External parties, maybe integration is not available to test it. If those dependencies are not managed effectively, it can increase the lead time. Approval and review process. If there are lengthy approval processes that occur after every active work is completed, it can extend the lead time. For example, long testing and quality assurance phase of the development can add a lead time. Resource constraints may be. Scope change may be during the development. Bottlenecks. There may be bottlenecks or checkpoints in the process that slow down the overall flow of the work. For example, if there is only one test available, it can bottleneck the testing phase, even if the development is quick enough. Handoffs and communications. Inefficient handoff between the teams or individuals, as well as poor communication between the team members, can lead a delay or misunderstandings, handover of delays. Waiting for the feedback can all contribute to a longer lead time. Work in progress. If you are aware of this Jira process, in Jira, in the Kanban board or in the Scrum board, the work in progress limit will be there. If you're not able to manage the work in progress limit, this work item never come to be work in progress until the existing work in progress items have been completed. See, in some agile methodology, if I read the statement as is, in agile methodologies like Kanban, teams use work in progress limits to control the number of tasks in progress. If these limits are not well managed, they can artificially extend the lead time as work items wait for a slot to become available. Process complexity. Highly complex process with many stages and decision points can naturally lead to longer lead times. Streamlining these, simplifying the process can help reduce the lead time. Then, as we develop the feature 4, okay, where the lead time is equal to the summation of all cycle times, where all delays has been is reduced a lot, reduced to zero. But if you see the feature 1 and feature 3, there is a difference in the development life cycle duration, right? Cycle time between the phase feature 1 feature time is more. You would understand why the development has taken more time. Then, if you understand all these difference, if you understand all these uh, reasons, and you can improve the efficiency of a project. To reduce the lead time while keeping the cycle time short, teams should focus on identifying and addressing the specific bottlenecks, delays, and inefficiencies in their processes. Lean and agile principles, such as continuous improvement, can be applied to optimize the workflow and minimize unnecessary wait times, ultimately delivering value to the customers more quickly. Thank you. Thanks for watching. I hope you understand the difference between lead time and cycle time. Thank you once again.